could factor out 4 of them. And that's what we did here. So one of those would be remaining right here. Then this had x minus 1 squared. This had x minus 1, so we could factor out one of those. Hey, how can I help you? Let's convert 152 kilometers to centimeters. All right, so when we're converting, we are not changing the amount of the number. The number itself might look like it's changing, but it's still the same amount as it was before. We're just changing the unit. So we'll still have the same length at the end of our conversion. It'll just be in a different unit. It'll be in centimeters instead. When I convert, I want to start with my given. My given is 152 kilometers. And we always put the given over 1 so that we can have a clear numerator and denominator. First things first. Oh, hello, Basil Mae. Yes, this is very interesting. Okay, you're done. All right, let me start over a little bit. I am going to convert from 152 kilometers to centimeters. I'm not changing the amount, I'm just changing the unit. It'll still be the same length at the end. The only difference will be instead of in kilometers, it'll be in centimeters. I'll put my given on top, put that over 1. First thing I'm going to do is I put kilometers on bottom, and I'm going to my midway, which is meters. This allows me to use the base 10, or the metric system worksheet, which has all of our base 10s, and it just makes our lives a little bit easier, and there are less things that we have to memorize. For every 1 kilometer, there are 1,000 meters, and I just wrote that in base 10 format, but 10 to the third is 1,000. And then I put kilometers on bottom so that it would cancel with the kilometers in my given. Next, I want to convert to centimeters. So I put meters on bottom to cancel this meters and centimeters on top. For every 1 centimeter, there are 10 to the negative second or 100th of a meter. I use the base 10s, and I always put the base 10s next to the meters to just keep things easy, to make sure that I use the same conversion method every time. Other teachers might have different methods. This is just my personal method. Okay. Now that I've done that, I can cancel kilometers and kilometers, meters and meters. Rewrite this, so I'd have 152 times 10 to the positive third times centimeters all over 10 to the negative second. And then I'm going to use the quotient rule for exponents, which states that when bases are being divided and they are the same, you subtract the exponents. So that'll be 10 to the third minus negative 2. Chop, chop. Those two cancel. So this will be 152 times 10 to the 5th centimeters. But we're not done, of course, because this isn't written in correct scientific notation. In order to do that, our A value, this first number, has to be between 1 and 10. So I'm going to take the decimal at the end and move it 2 times. And because I moved it 2 times to the left, that means I'm going to increase my exponent by 2. So my final answer is going to be 1.52 times 10 to the 7th centimeters, or 15,200,000 centimeters. Remember, that is the same length, the same distance that we had before. The only difference is that we are expressing it in centimeters instead of kilometers. Okay, so now let's do a conversion where we already have our given amount in base 10. So we're going to convert 1.15 times 10 to the 4th millikelvin to nanokelvin. Millikelvin. Now, there are some of you who are saying, oh, well, if we're going from millikelvin to nanokelvin, that's an order of 6 magnitude difference. I could just go ahead and add that to my exponent, and bam, bam, we're done. Well, you are not incorrect at all. That's definitely what you could do. But that involved mental math, and although some of us are good at mental math, not everyone is good at mental math, and mistakes tend to happen in mental math. So we always want to make sure that we know how to do it by hand. So we start with our given. 1.15 times 10 to the 4th millikelvin. That goes over 1. And then we would put millikelvin on bottom and Kelvin on top. This is a very cold temperature. I do not want to be in millikelvin whatsoever. I guess it isn't. Yeah, that's still pretty cold. So we'll go from, for every 1 millikelvin, there are 10 to the negative third Kelvin, or a 100th or 1,000th of a Kelvin. Bleh, I can't talk. Then we'll convert from Kelvin to nanokelvin. For every 1 nanokelvin, there is a billionth of a Kelvin, or 10 to the negative 9th Kelvin. Now, once we've done that, I put millikelvin on bottom here so that would cancel. So those two cancel, and then my 2 Kelvin cancel. So nanokelvin is left over, and that's what I wanted to convert to. So I'd rewrite this 1.15 times 10 to the 4th times 10 to the negative 3rd nanokelvin. There we go, nanokelvin, all over 10 to the negative 9th. And now I'm going to do the base 10 simplification in 2 parts. So first of all, we would use the product rule for exponents, which states that when 2 bases are being multiplied and they are the same base, we add the exponents. So 4 plus negative 3 is equal to positive 1. So we can rewrite this as 1.15 times 10 to the 1st nanokelvin, all over 10 to the negative 9th. And now, when we have 2 bases that are being divided, that's the quotient rule for exponents. So we take the top minus the bottom. And 1 minus negative 9 is chop chop, positive 10. So our answer is 1.15 times 10 to the 10th nanokelvin. So you can see that way back here, we said that we could have just added a 6 order of magnitude difference and got the same answer. That's exactly correct. We could have done that. And I've just shown with my math that that would be correct. You always want to make sure to know how to do it both by paper way. You want to have your apps, but all the different ways. I'm babbling at this point. Know how to do it by hand. It's not that bad. You can do it. Okay. Let's go ahead and do a speed conversion. Speed conversions are when you have miles per hour or kilometers per hour or meters per second, as we commonly see in science. So let's convert 15 meters per second to kilometers per hour. Now normally when we set up the given, we just put our given over 1. The reason that we've been doing that is because we haven't had any value in the denominator. But here we do have a value in the denominator, and it's in our denominator. It's the unit. So when we set up our given, we put the unit in the denominator. So that's how we set up a speed problem. This is in the numerator, it goes in the numerator. This is in the denominator, it goes in the denominator. Now, we need to convert both meters to kilometers and seconds to hours. I'm first going to take care of meters. Put meters on the bottom, just like we always do, so that they cancel. And then I put kilometers on top. And for every 1 kilometer, there are 10 to the 3rd, or 1,000 meters. I'm done converting the top part. I'm done converting the meters. So now all I need to convert is the seconds. Because seconds is in the denominator, that means that I'm going to want to put seconds in the numerator. There's seconds. And I will convert to hours. I could have also done seconds to minutes and then minutes to hours, but I'm just going to go seconds to hours because I know that for every 1 hour, there are 3,600 seconds. 0. So check it out. Meters cancels with meters, seconds cancels with seconds, and I'm left with kilometers per hour. So when I rewrite this, I have 15 times 3,600 times kilometers all over 10 to the 3rd. Remember that 10 to the 3rd as a base 10, that's 1,000. I don't have any other base 10s, so I might as well just express that in standard form instead. Then I've got hours on the bottom. Okay, let's go ahead and calculate. So I'm going to do 15 times 3,600. That's my top. Multiply those together, and then divide by the bottom, 1,000. And I get 54. So that means my answer is 54 kilometers per hour. And that's it.